Take out your background.
Later.
Later.
Yeah. Okay, so here we go. We're going to evaluate the next integral on our list, and it goes from 0 to infinity. And it's 2dx over x squared plus 4x plus 3. I smell a partial fraction decomposition, but let's look at what's going to happen here. We're going to look at the limit. We're going to look at the limit. Yikes, not that. Here we go. The limit. Let me get to, jeez. The limit as a approaches infinity of the integral from 0 to infinity of 2dx over, I don't know why I'm shaky here, x squared plus 4x plus 3.
You wrote out the question again.
But with a limit.
Okay.
And so now what we're going to do is we're going to take the 2dx part, 2 over x squared plus 4x plus 3, and we're going to do a partial fraction decomposition. A over part plus b over a part. So this is going to be x plus 3, x plus 1, and this factors over here to x plus 1, x plus 3, and multiply by what each denominator is missing. So this guy needs an x plus 3, this guy needs an x plus 1. And we have now, from our partial fractions, 2 equals a times x plus 3 plus b times x plus 1. And we're going to let x equal negative 3 and x equal negative 1. Okay? And remember, we're doing this because we want to find out what a and b are. So this is the whole partial fraction situation. All right? 2 is equal to a times negative 3 plus 3 plus b times negative 3 plus 1. So 2 is equal to negative 2 times b, which is negative 1. When we do this again, we get that 2 is equal to a times negative 1 plus 3 plus b times negative 1 plus 1. So 2 is equal to 2a, so a is equal to 1. All right, so here's my setup then. This integral changes, and it becomes not the integral of this guy, but the integral from 0 to infinity. That doesn't need to be an infinity. I should have caught that a second ago. This needs to be an a. 0 to a of 1 over x plus 1 plus negative 1 over x plus 3 times dx. And so when you integrate this, we're looking at natural logs, okay? And this is going to end up being a natural log of x plus 1 minus, if you want, minus the natural log of x plus 3. And we're going to evaluate all of this from 0 to a. And the reason it's just natural log is just think about if I have 1 over x plus 1 and I just integrate just that guy. That's the same as integrating 1 over u and letting u equal x plus 1. So du dx is just 1. So when I integrate this guy right here, when I integrate that guy, he becomes, remember, just the natural log of u. So my u in this case is x plus 1, and my other u is x plus 3. Okay? And when you subtract logarithms, you end up dividing. So I'm actually doing the natural log of x plus 1 over x plus 3 from 0 to a. Okay? Keep going now, and we'll do stop minus start. This is going to be the natural log of a plus 1 over a plus 3 minus the natural log of 1, 0 plus 1 over 0 plus 3. Okay, so here's where we're at. And when we sort all of this out, we wind up with the natural log of, let's go ahead and leave it in fraction form, a plus 1 over a plus 3 minus the natural log of 1/3. So that natural log of 1/3 is all it is a number. And so when we go back then and look at the limit, we're looking at the limit as a approaches infinity of the natural log of a plus 1 over a plus 3 minus the natural log of 1/3. Okay, and what happens is this guy right here grows and grows and grows and grows, and actually is going to approach 0. Okay, and so you end up with, as you go to infinity, you end up with a 0 here. All right, because this is, remember, a over a, as those go to infinity, as those leading coefficients go to infinity, you're getting really close to 1. As you get really close to 1, the natural log of 1 is 0. Okay? And since the natural log of 0 is 0, what we end up with is 0, and then the minus the natural log of a constant, or minus the limit of a constant, is just that constant. So we should get negative natural log of 1/3 for a final answer on this partial fraction problem. A lot of steps, but do a little bit at a time and you should be okay.